Hey guys, welcome back. So what we're going to look at today is Lesson 9, the Distributive Property, Part 1. We're also going to take a quick look at one little thing in Lesson 8. Now, you will not have to do Lesson 8 practice problems, but I just want to make sure that you see it so you understand how, what equivalent expressions look like and how we can write expressions different ways, okay? So let's go ahead and jump right in. So identify equivalent expressions. Here's a list of expressions. Find any pairs of expressions that are equivalent. If you get stuck, try reasoning with diagrams. So here we have a plus 3. Here we have a plus a plus a. Are these two the same? No, they are not, because here this is having 3 a's. So that'd be like multiplying a by 3. So these two, whoops, that didn't actually work. So these two are actually connected. Now, having a plus 3 is the same as having 3 plus a. Those two are the same. So I'm going to use a different color to identify that this one and this one are equivalent to one another. Now, I have mentioned it a few times, but not very often. When we have a variable, we can put a 1 in front of our variable, and it represents the same thing as just having our variable. So for some people, it's nice to see that 1 there because it helps you in remembering, okay, I'm taking 3a and I'm subtracting 1a, not just subtracting the a away and making it so it'd only be 3. I have a lot of times where people get that confused. All right, the next two here, we're taking a and we're dividing it by 3. Is there another one where we divide by 3? Yes. This one right here. 1/3 a is the same thing as saying a divided by 3. So they match up. All right, now we have 3 times a. 3a is the same thing as saying a times 3. So this goes back with our first ones that we looked at. And then last but not least, remember when we divide by a fraction, it's same times flip. So it end up being 3 over 1 that we'd be multiplying by, so those 3 are the same. So there's a lot of different ways to express having that multiplication, having 3a. We can do a plus a plus a. We can do a times 3. We can do 3a. We can do a divided by 1/3. They all represent the same thing. So just a little information there on equivalent expressions, okay? Now, like I said, lesson 9 is the only one that you have to do practice problems for of this video. So, ways to represent area of a rectangle. Select all of the expressions that represent the area of the large outer rectangle in figure A. So, in figure A, we know we've got one side here that is 6, and we've got a side here that is 3. So, to find the area of this rectangle, the smaller one, we just do 6 times 3. So we could do 6 times 3 plus 6 times 2 for the other one. So this middle one this one right here would be a possibility. It'd be the sum of the two areas added together. Now, another option would be to find what this side here is. 3 plus 2 is 5, so we just do 6 times 5. There's another option. The next option, we can take 6 times the sum of this side, so 3 plus 2. So this one right here. So different ways to find that area. So these are kind of working us into what the distributive property is and showing us how that works. So the next one, B, we are selecting all the expressions that represent the area of the shaded rectangle on the left side of figure B. So if we look at this, we only want the blue part. So we know this whole side is 7. So to find the blue part, we'd do 7 times 4, which would give us 28. That'd be the whole thing. And then 7 times 2, which is 14. And then we'd subtract those. So that's this one right here. 4 times 7 minus 4 times 2. Well, said a little differently. We can also do 4 times 7 minus 2, because that's what that length would be on the shaded. And then if we take 7 minus 2, that's going to give us 5. So this would also work. So all of those equal 20. All of the ones up above are going to equal 30. So remember your order of operations when we do these. All right, so distributive practice. Complete the table. If you get stuck, skip an entry and come back to it, or consider drawing a diagram of the two rectangles. So your keyword for this lesson is distributive. So what we are doing here is we have this first example, 5 times 98. Now, do we know that right off the top of our heads? No. But we can change 98 into 100 minus 2. That still gives us 98. And so we write it as 5 times 100 minus 2. So then that means we take 5 times 100 and we take 5 times 2 and we subtract them. So 5 times 100 is 500. 5 times 2 is 10. 500 minus 10 is 490. So the value of 5 times 98 is 490. So the next one, we have 33 times 12. Not the easiest to calculate off the top of our heads. But we could split the 12 into two things. So we have 10 and 2. Those are much easier to multiply with. So 33 times 10 is the first thing we do, plus 33 times 2. 33 times 10 is 330, plus 33 times 2 is 66. Now we add those together. 330 plus 66 is 396. Now on this next one, we're not given what the original is. We're given these two columns. So 30 minus 12 is what? Well, 30 minus 12 is going to give us 18. So our answer is 18. Now we work backwards to figure out what the original problem was. So here we see that we're multiplying 3 to both 10 and 4. So we're going to have 3 times 10 minus 4. Well, what is 10 minus 4? 10 minus 4 is 6. So our original problem was 3 times 6. All right, our next one, we have 100 times 0.04 plus 0.06. If we add 0.04 and 0.06 together, we're going to get 0.1. So we're taking 10 times 0.1. So here in the expanded, we're going to have 100 times 0.04 plus, oops, that's supposed to be a plus. It looks weird. Plus 100 times 0.06. So we find what those are. 100 times 0.04 is 4. 100 times 0.06 is 6. 6 plus 4 is 10. All right, our next one, we have 8 times 1/2 plus 8 times 1/4. So we know it's 8 times, what's 1/2 plus 1/4? And that would be 3/4. So we have 8 times 3/4. 8 times 1/2. So 8 divided by 2 is 4. 8 divided by 4 is 2. So 4 plus 2 is 6. All right, this next one here, we have 9 plus 12. 9 plus 12 is what? 21. Now, we need to figure out what column 3 would be. Well, what do 9 and 12 have in common? They're both divisible by 3. So 3 times what gives us 9? That would be 3 plus 3 times what gives us 12? 4. So here we'd have 3 times 3 plus 4. 3 plus 4 is what? 7. So 3 times 7. All right, the last one, we have 24 minus 16, which is 8. So what do 24 and 16 have in common? What are they both divisible by? They are both divisible by 8. So 8 times 3 gives us 24, minus 8 times 2 gives us 16. So we have 8 times 3 minus 2, which is 8 times 1. Now, obviously, on some of these, we don't really need to take and expand it out like this. That just makes more work to find the answer. But on ones like 33 times 12 and 5 times 98. Using this can help us, and eventually we'll throw in variables into this and use the distributive property with our variables as well, and this will keep expanding. So the distributive property will keep expanding more and more as we progress through mathematics in your life. So if you guys have any questions, feel free to ask. Have a great day. Bye, guys.